Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about the recovery with the concurrency control. That means if the two transactions are executing concurrently and we have made it to the log records, how can we recover these transactions that are being updated with each other? We will know about the interactions with the concurrent execution, then perform the recovery, checkpoints, and using the checkpoints, how we can restore the recovery in this concurrent execution. Concurrent execution of two transactions means that the transactions are executing simultaneously. Now, for the concurrent execution and that the atomicity and consistency requirement of a concurrent execution needs that we either go for a timestamp or locking on an item. So the locking on an item can be ensured by having an exclusive and shared mode lock concept by a two-phase locking protocol. Now, while we can have this type of locking and timestamp, which is the timestamp or a system clock that is associated with each of the transaction as the starting of the transaction. And there are some rules based on these transactions so that we cannot occur in an inconsistent state such that the right timestamp queue, if it is less than this TS on the timestamp of a transaction, then we cannot just write the value because already the value has been modified, because the right timestamp queue goes for the largest time that is the value for modification on an item. Now, by this timestamp and locking mechanism, we can ensure that the concurrent execution of two transactions do not go in an inconsistent state. But what happens inside a log record when the log is maintaining all the transactional records for concurrent executing transactions as well as the isolated transactions? Now we can have the log records of this type of execution as a whole. So there is no way that one transaction is going in an inconsistent state or a non-atomic nature to find it inside a log. Now, when we are putting into the log, that means the transaction is fine. But can the transactions be performed with the other transactions synchronizingly with it? So that is a problem within concurrent execution. Now we can find in this log record that how we can recover from these failures. Say with the concurrent execution, we can either roll back a particular transaction. Now we can roll back the transaction by performing in the log records undo of this particular transaction. That means now my TI will contain all the previous values that the transaction has been modified on any data items. Now this rollback TI is a logical concept, whereas an undo TI is a physical concept, because there is no rollbacking inside the log. Only we can logically undo it inside a log to get the physical effect to it. But suppose there are some problem with the concurrent nature with this recovery. We cannot just undo and roll back it with the isolated transaction concept. Say suppose that we are having two problems with two transactions, T0 and T1, they are concurrently executing, as with some logs that are predefined with a timestamp. Now say suppose that T0 is having a data item and it has been rolled back that data item. That means T0 has performed queue on modification. Now we can have the T0 queue on a lock item, and after the modification it releases the lock. So first it gives this X lock on this queue, then it release lock on queue. So this is done by T0. Now after that T0 has been aborted. Now what happens, this abortion of T0 is followed by some transaction T1 that wants to update the value of Q. That means now T1 gets an exclusive lock of Q as soon as the T0 can release this lock. Now my T1 gets an exclusive lock on Q to update the value. But before the T0 has been rolled back, that means the T0's effect on Q we do not want to modify. But when the T1 is having this Q, it has the modified value of Q, not the undone value of Q, because the abort or this T0 has been performed. So now the problem is that exclusive lock granting and releasing. So we can do this by providing a two-phase locking protocol where we can acquire the lock while being the transaction, and we can release the lock after the transaction has either been committed or being aborted. Now the commit or abort signify the transaction has finished its execution, either successfully or unsuccessfully. Now you can release the lock on a data item that the transaction is having. So this just solves the problem that the T1 can get an exclusive lock after the T0 queue has been made to the new modified value, or it is desirable to have the old value or the new value. Now we can roll back the value if it is an abort, and after that releasing the lock, the T1 will have the old value, and if it is in commit and then the T1 is getting, then it will get the new value to T1. So this is one concurrent nature, that is the interaction with a concurrent execution of two transactions by phasing this two-phase locking protocol, which ensures that one can release the lock only after the transaction is being committed or aborted. Now there is one more problem with this transaction rollback that we can have in this transactional on the concurrent execution. Say suppose the log record consists the value that is TI, XI, V1, V2. Now what happens in this transaction? The TI is making this XI value from V1 to V2. That we know that for a log record we can maintain this type of information. But what happens that when perform a transaction rollback on TI? So this transaction rollback on TI will make this XI to this V2 and before this V1 value. Now if there is any transaction that tries to modify the value before the lock has been released, that means before the transaction has been committed, so how can we imply this two-phase locking protocol inside a lock? Now let us exemplify our question and then solve by this example. Say suppose we are having two transactions in this log. One is T1 A. Now if we perform this transactional rollback on this T1, then what happens that for T1, if there is any another T2 that wants to modify it after A. So if T1 is followed by T2, then after rollbacking we can get that from 30 to 20 or from 20 to 10. So if we roll back this transaction T1, we can have this 10, where in this T2 we have the value of A as 20. So that becomes a problem because it is giving us an inconsistent value of A. So now what we can do to provide this two-phase locking protocol, then if a value that has been modified by a transaction, then after committing the transaction or aborting the transaction, one can only go for the updation on that transaction. Say suppose that T1 has updated the value to 10 to 20. So now T1 either needs to commit its transactions or it needs to abort its transaction. Now if T1 commits, then A have 20 to it, and if it's abort, then by rollbacking E have 10 to it. Now if T2 goes with the value of A with the commit, he can go with this 20, or with the abort it can go with this 10. So this is the exact format in the log how we can maintain this two-phase locking protocol. Now there is another problem that is related to this transactional rollback. If we move back to our previous problem, that's T1A 10 20, and then we have T1A 20 30. Now what happens if we recover from the lock by this rollbacking transactions forwardly? So first we are having this 10 20, that means the previous value is 10 now, so A is having 10, and after that 20 30, no, so my A is having 20, which is not a correct result because the transaction's old value was 10, which is being modified to 20 so that we can modify back to 30. So now my A has 20, which becomes an inconsistent and undurable result. So to follow this one, we need to scan the log backward for any undoing operation. That first we need to perform 30 to 20 and then we can have rollbacking it to 10, which is the correct result. So forever when there is an undoing operation, we need to perform the scan in a backward nature. Now that leads to the concept of checkpointing. Now what is a checkpoint? After some operation or after the transaction that has been performed inside a log, we can perform a checkpoint to the log so to indicate that till now we have considered all the transactions completed either successfully or unsuccessfully. That means they have been modified to the new value or they are pertaining their old value. We do not need to perform the recovery algorithm before the checkpoints. So the checkpoint introduction in a log is extremely important because this checkpoint can suggest that anything before this checkpoint in the log, we do not perform the recovery algorithm. So what we can perform that from this checkpoint and the next checkpoint where we can have, we scan the log backwardly so that we can have all our undoing and other recovery techniques that we will know later about from this checkpoint to this checkpoint, that from the recent checkpoint to another checkpoint. But if we have two checkpoints consequently, then there is no need to go back for this previous checkpoint as already we are having a most recent checkpoint. So it is always go for the most recent checkpoint in the recovery technique. So if we are checkpointing from time to time, that means we are keeping up to date with our log records, which will require a less amount of recovery cost to be attached with this log. Now what happens with this checkpoint? The disadvantage that within the concurrent execution too, the checkpoint, if it is introduced in the log, then there is no disk buffer that we can update with the value until and unless we find a checkpoint. That means if the checkpoint is at the last of the log for a shorter log, then we cannot perform any update till the end of the log, which is the end of checkpoint or the most recent checkpoint. Now the concept arises with the weight of this disk buffer that weighs the CPU cycles by considering the disk buffers full for until we are having a checkpoint. So there a concept arises with the fuzzy checkpoint where we can logically perform the updation on the database modification even if we are not reaching the checkpoint. And this logical updation only performed only there is a need of the one variable, that is the updated value, which will be needed by another transaction. Say suppose that T1 has committed and after that T2 is needed, but there is no checkpoint till now. So how can we get this update of A 10 to 20 here in this checkpoint? We can help this with this fuzzy checkpoint where we can make this A 20 so that we can have to update this transaction from 20 to 30. Otherwise, this would have been a problem because T1 still remains A for 10 if we use a checkpoint. Now with the concurrent execution, we have to go for two situations. That one, before the checkpoint, we do not need to perform to check any transaction that has problem or not, and we can check only after the most recent checkpoints all the transaction, and one transaction that is active at the time of this most checkpoint. That means there is one transaction that was present at the time the checkpointing was done. So that transaction we need to again consider for either redoing for undoing. Another one is for the concurrent execution, as there are many transactions or at least two transactions executing concurrently, then it can have that at the most recent checkpoints we have two or more transactions active at that time. So now we need a checkpoint L with the L is considered to be the list of the active transactions at the most recent checkpoints with the concurrent execution of the transactions. Now after that we made this fuzzy checkpoint and the concept of checkpoint list L, then we can restart our recovery technique. Now first we need to scan the log backwardly. For any of this checkpoint if we can have, then we will start from the recent transaction and then go backward till we find the recent checkpoint starting. That means the checkpoint and the transaction TK. So we need to perform all this one TK to this checkpoint and the active checkpoint transaction 2 for our recovery technique. Now there are some rules to restart our technique. We can make two lists out of this one, that we can only perform for the recovery technique in a log record with the redo and undo. So now we want list from the redo and one list for the undo. So now if this TK is in the format of TK commit, then we will put inside this in a redo list, so that we can say that if any transactions form in the T commit, then we put TK into our redo list. Now we will check for the next one. Now if we found this TK commit, we just put it into the redo list because the transaction has completed its successful completion. Now what happens if we found some transaction in the format TK start? Then we check for the transaction TK into the redo list. If it belongs to the redo list, that means the transaction has committed and also started. So we do not need to perform anything. But it doesn't belong to this redo list, then we need to add to this undo list. That means the transaction has started but neither committed or nor aborted. So we need to undo that particular transactions. So in this way we can find our redo list and undo list. But one more thing we need to consider about the checkpoint active transactions. Now we need to check for the checkpoint list L. So first we record all the list that is belonging to L. So every TK in L that we need to check for the redo list. So if the TK belongs to L, then we need to check for the TK in this redo list. So if the TK belongs to L and also into the redo list, then we need to perform nothing. That because already it is added to the redo list for the active transaction. If doesn't belong to this TK to the redo list, then we must add it to the undo list. Now we have our final undo list and redo list for the redoing and undoing. Now what we can do, we first need to do all the undos that by scanning backwards. That means from the now recent transaction that is in the log, we need to again scan the log backwards so that we can find all the transaction in the undo list. So if there is from TI to TK, the transactions, so we need to perform the undone on this undo list from TK to TI backwards, so that after in backward we are performing undo on the undo list, and on the transactions that belong to the undo list we need to perform forwardly to find the most recent checkpoint L. Now why we are going within forward checkpoint? Because if we find the most recent checkpoint backwardly, then we might not have taken that all the checkpoints that was been previously considered. So we forwardly find the checkpoint L, that is the most recent checkpoint. So after finding the most recent checkpoint, we need to perform the redo list also in the forward nature. Now why we need the redoing forwardly and undoing backwardly? Because undoing it means that the previous result need to be undoing first, so that we can get the previous value of the latest result as the new value of the previous result. so that we can undo it in a proper manner. But the redo is exactly the same on this opposite side. That means, say suppose that A is deducted with 50 and only the deducted amount can be added to this B. That means first we need to perform redo on A and then redo of B, not B and A. So now we need to perform this redo list with all the redos in a forward nature. Now with the help of an example, we will look for that why it is absolutely important to first perform this undo and then this redo from the checkpoints. Say suppose we have a log within record Ti and Tj that is executing concurrently. So now from the listen checkpoints we have Ti that will make the A item to 20 from 10. Now there is one other transaction Tj that is making this A from 10 to 30. After that we can have Ti commit. So what it checks for the checkpoint rule, that first it goes within commit, and if it is in commit then put it into the redo list. So we can perform this redo Ti. And also we cannot have this Tj committed, so we need to perform undoing Tj. Now our steps for the recovery says first undo and then redo. What happens if we first redo and then undo? If we perform this redo on Ti, that means we are having 20 as a result of Ti. So now my A have 20. Now we are undoing Tj, that means the 30 value goes for 10. So my A have 10 now, which is an incorrect result because we cannot see the effect of A, that is 20 now. But if we perform undo first and then redo, that means from backward we need to first undo this effect to 10. That means now my A have 10, which is the I on this Ti made to this 20, which is the new value of redo. That means now my A equals to 20, which is the exact result on the modified one that we want to preserve. So that is why for the problematic result that we can have from a wrong one within recovery technique, we need to choose first undo then redo with every recovery technique. So that is all for the concurrent execution that we can perform with find the log records, transactional rollback, finding checkpoints, and then doing the steps for the recovery, first undo and then redo. Undo in backward nature and redo in forward nature also, it is very important. So thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.